Students, so today's topic is basically electric field. Clear? So we know that two charges can exert force on each other without coming into contact. They can exert force to one another without coming into contact. There is no physical contact required. That means there must be something which is present there and which is not visible, which we called electric field, just like gravitational field around a mass or around a body which has mass. So this is a similar topic called electric field. So first of all, we will see the qualitative explanation of electric field. That means what is basically electric field. So suppose let us consider a positive charge. This is a positive charge and let its name be Q. So it is a positive charge and we are discussing about the electric field of this charge. We are discussing about the electric field of which charge? Of this charge. So this is the source of electric field. That is why we will name this charge as source charge, because here this charge is the source of electric field, or we will discuss or we will talk about the electric field of this charge. That is why the name of this charge is source charge. Clear? Now what is electric field? What is electric field? So it is a space. It is a space around this charge. It is a space around this charge. It is an environment around this charge. What kind of environment? Electric environment around this charge. And what is the property of that field which is around this charge, or what is the property of that environment which is around this charge? The property is that if some another charge, if some different charge, if any charge comes into this environment, it will experience electrostatic force, or simply you can say electric force. Clear, students? So what is electric field? What is electric field? It is a space, it is a space, it is a field, it is an environment around a charge, and if some other charge comes into this environment, it will experience a electrostatic force. It will experience an electrostatic force. Clear, students? Now let us answer few questions. Let us take a point P. We have named this point as point P. Now the question is whether electric field do exist at this point P. Do electric field exist at this point P? Which charge is the source of the electric field? This charge. We are discussing or we are talking about the electric field of this charge. Now the question is, this is any point P here. Now do electric field exist at point P? So to test the existence of electric field at this point P, we'll put a charge, a positive charge called test charge. Why its name is test charge? Because we are basically testing whether electric field do exist at point P or not. So to test the existence of electric field at point P, we placed one charge Q0, which is a positive charge, and that is why its name is test charge. Now if it experiences electrostatic force at point P, then we will say that yes, electric field do exist at point P. And if it does not experience any kind of electrostatic force at point P, then we will say that there is no electric field at point P. Clear? So now let us consider that electric field exists at point P. That means it will obviously experience some electrostatic force. So because we have considered this test charge as positive charge, so by convention we always consider test charge as positive charge. So it's by convention only. We have just taken it as positive charge. So if it is a positive charge and if electric field due to this charge exists at point P, then obviously this charge will experience some kind of force. Some kind of force means which force? Electrostatic force. So because it is a positive charge, it will experience repulsive electrostatic force. Clear, students? So what is electric fields? This must be clear so far. Now we will see the quantitative explanation of electric field. Clear? What is electric field? It is basically qualitative discussion. Now if I ask you, okay, electric field exists at point P, now calculate what is the electric field. Calculate the electric field at point P. Because Q0 is experiencing some electrostatic force at point P, yes, electric field exists at point P. But now you need to calculate. You need to calculate electric field at point P. Now you need basically the quantitative explanation of electric field. Clear? Students, now we will see what is electric field at a point. What is electric field at a point, which is basically the quantitative explanation of electric field. So what is electric field at a point? It means the force exerted on a unit positive charge. Unit positive charge. You can write +1. Force exerted on a unit positive charge at that point. What is electric field at a point? The same moment it must come to your mind that it is the force exerted on a unit positive charge at that point. Clear, students? So in SI we can say that at a point the force exerted on 1 coulomb, the magnitude of the force exerted on 1 coulomb is the magnitude of the electric field at that point. Clear? And at that point the direction along which a positive charge will experience force will be the direction of electric field at that point. This definition need to be very much clear. At a point, what is the magnitude of electric field? It is the force exerted on unit charge, that means 1 coulomb in SI. And what is the direction of electric field at that point? Here we have written it's positive. That means the direction along which a positive charge will experience force at that point, that will be the direction of electric field at that point. So simply by combining these two, we can say that what is the electric field at a point? It is the force exerted on a unit positive charge at that point. Clear? So for example, we know that electric field exists at this point because Q0 is experiencing some electrostatic force F at that point. So electric field do exist. Now what is the magnitude of electric field at this point? What is the magnitude of electric field at this point? So if Q0 is experiencing F, if Q0 at point P, if Q0 is experiencing F, then obviously unit charge will experience F by Q0. And what unit charge experiences, that is basically the magnitude of electric field. So what will you write? What is the electric field at this point? You will write it simply F by Q0. But a lot of students consider this as a formula, but this is not a formula. You just need to understand the definition. If I ask some students, yes student, what is electric field at a point? Some student replies, sir, it's E equals to F by Q naught or E equals to F by Q. No, this is not the correct way to know what is electric field at a point. You just need to know the definition, and later you will apply this definition everywhere to find the electric field at a point. So you know that electric field at a point is basically the force exerted on a unit positive charge at that point. Clear? So here Q naught is experiencing F. So unit charge will experience F by Q, and what unit charge experiences is basically the electric field at that point. So this is the magnitude of electric field at this point. Q naught is experiencing F, so unit charge will experience F by Q. It is the magnitude of electric field at this point. Now electric field is not a scalar quantity, so you must know what is the direction of electric field at a point. So it is the force exerted on a unit positive charge. Now if you see, the nature is positive. That means at any point, the direction along which a positive charge experiences force, the direction along which a positive charge experiences force, that direction will be the direction of electric field. So here we have considered this test charge as a positive charge, and it is experiencing repulsive force along this direction. So this is the direction of electric field at this point because it is a positive charge. The direction of force exerted on a positive charge at a point is the direction of electric field at that point. Clear students? So instead of writing E in vector form, that means we can also include the direction here. It is like this. Clear? Students, now we will see what is the SI unit of electric field. So let us recall the definition again. Electric field at a point is the force exerted on a unit positive charge. It's the force exerted on a unit positive charge. Or from now only you have seen that it is equals to F by Q. Now only you have seen that. Or without using this formula also, we can find the SI unit of electric field. It's force exerted on unit charge. For example, it's 20 Newton at a point. At a point, electric field is 20 Newton per coulomb. That means at that point, 1 coulomb is experiencing 20 Newton. Clear? So what is the SI unit of electric field? Is Newton Coulomb inverse. Or from here also you can see it's force by charge. So what is the SI unit of force? It's Newton. And what is the SI unit of charge? It's Coulomb. So Coulomb will go to the numerator. It will become Coulomb inverse. But sometimes you will also see that the SI unit of electric field, they will write volt meter inverse. So how SI unit of electric field becomes volt meter inverse or volt per meter, you will come to know about this in the next chapter, when we will deal with potential or potential at a point or potential difference between 2 points. Then we will come to know that how SI unit of electric field becomes volt meter inverse 2. Clear? So students, now we will derive one expression for electric field due to a point charge at a distance r from it. Now we are just considering the distance as r. So we are given a charge q. We are given a charge q which is at point O. Let us consider that this charge is of positive nature. So we are given this charge q which is at point O, and we wish to find its electric field. We wish to find its electric field, so we will name this charge as source charge. So we need to find its electric field at this point. Let us name this point as P, which is at distance r from this charge. If this is r vector, then obviously this distance is r. You must know these things from class 11. If this is r vector, then this distance is r. So we wish to find electric field at this point due to this charge, and this point is at distance r from this charge. Clear? So the question is over. So to find electric field at this point due to this charge, we will place a test charge Q naught, which is again considered as a positive charge. To find the electric field at point P, what you have placed at that point? A test charge Q naught. So obviously, because electric field exists at point P due to this charge, so obviously Q naught will experience some electrostatic force. So let us consider that it is experiencing F. It is experiencing F. It is experiencing F due to this charge. And from Coulomb's law, we can find this force F. Clear? So from Coulomb's law, you can write from Coulomb's law. I am not writing the entire language here. I will also attach the notes PDF format. In the PDF format, you can see the language from that note only. So from Coulomb's law, we know that force exerted on this charge Q naught due to this charge will be given by 1 by 4 pi epsilon naught product of two charges divided by square of distance between them. Clear? Clear? So this is the force exerted on Q naught due to this charge. And how we have written 1 by 4 pi epsilon naught? So we are just considering that this medium is vacuum. Because this medium is vacuum, we can write 1 by 4 pi epsilon naught in the place of constant here. So this is the force exerted on Q naught at point P. That means electric field at point P. Electric field at point P. It means the force exerted on unit positive charge at point P. Electric field at point P. That means you need to find the force exerted on unit positive charge at point P. So what force Q naught is experiencing at point P? It is F. What force Q naught is experiencing at point P? It is F. So at point P, if Q naught is experiencing F, then unit positive charge will experience F by Q naught. Very simple, which is the magnitude of electric field. Now we know what is F here. It's 1 by 4 pi epsilon naught Q naught by R square. It is basically 1 by 4 pi epsilon naught Q naught by R square. So Q naught and Q naught will get cancelled out. So we will have 1 by 4 pi epsilon naught Q by R square. This is the magnitude of electric field due to a point charge Q at a distance R from it. This is the magnitude of electric field due to a point charge Q at a distance R from it. Clear, students? Now, because electric field is a vector, we must know how to write this expression in vector form also. So in vector form, we'll just add the direction here, nothing else. So here in this case, positive charge is experiencing force along this direction. Positive charge is experiencing force along this direction. Clear? And what is this direction? It is r cap. This direction is r cap. So simply you can write r cap. If this is r vector, then what is this direction? It's r cap. So, you have written electric field in vector form too. Clear, students? Students, now let us consider a sphere of radius r and a point charge q is there at its center. This is a sphere of radius r and a positive point charge is there at the center. Now what will be the magnitude of electric field at any point on the surface? It is E equals to 1 by 4 pi epsilon naught charge by distance square. It's q and the distance is r, so it's r square. Every point on the surface of the sphere, at every point on the surface of the sphere, the electric field, the magnitude of the electric field due to this charge will be equals to this. Because every point on the surface will be at distance r from this point, that is center. That means if the charge is at the center of a sphere, then on the surface of the sphere at every point the magnitude of the electric field is exactly equal. We cannot say that electric field is same because electric field is a vector quantity. Directions at every point will be different. Let us see. What will be the direction of electric field at this point? It is along this direction. We will say how? Place one positive charge, it will experience repulsion because we have considered these as a positive charge. So it will experience repulsion along this direction. So this is the direction of electric field. What is the direction of electric field at this point? It is along this direction. Because positive charge will experience repulsion along this direction. Or what is the direction of electric field at this point? It is along this direction because positive charge at this point will experience repulsion along this direction only. Clear, students? So electric field is not same at every point on the surface. If you say just electric field, that means you are also including the direction. You can clearly see that directions at every other point is different. So magnitude of electric field is equal at all point on the surface. Now if you see the direction of electric field, it looks spherically symmetric. That means, now consider that you are at the center of this sphere. You are at the center of the sphere. Now if you look around, you will see that in every direction the electric field looks similar. In every direction the pattern of electric field looks similar. That is why we call it spherically symmetric. And it is also called radial field. Clear, students? Students, now let us solve one problem. The problem is a pendulum of mass 800 milligram carrying a charge of 2 multiplied by 10 to the power minus 8 coulomb and is at rest in a horizontal uniform electric field. So let us consider that this is a region of uniform electric field. This is a region of uniform electric field along horizontal direction. So uniform electric field means at every point in this region the strength of electric field will be exactly equal, and at every point the direction of electric field is along the same direction. Here in the question it is given that the field is along horizontal direction. So I have just considered that the field is along this direction and this is a region of uniform electric field. Okay. and the charge present in the pendulum is 2 multiplied by 10 to the power minus 8 coulomb. And the mass of the pendulum, that means they are talking about the bob in the pendulum. The mass of the bob is 800 milligram. Okay. And the strength of electric field is also given. It's 2 multiplied by 10 to the power 4 voltmeter inverse. I have already said that voltmeter inverse is a unit of electric field or SI unit of electric field. Find the tension in the thread of the pendulum. We need to find the tension in the thread of the pendulum and the angle it makes with the vertical. So let us try to draw the figure. So this is the vertical direction, and let us consider that the pendulum is making angle theta with the vertical direction. So this is the pendulum or bob of the pendulum whose mass is 80 milligram. So let us consider that its mass is mg. Sorry, let us consider that its mass is m. So its weight will be mg. If I consider that its mass is m, then its weight will be mg towards downward direction, that we know. Let us consider that the charge present in this pendulum is q. The value of charge in the pendulum is given. So now I am considering that the charge present in this pendulum is q. So students, here in this region of uniform electric field, at any point, what force does a unit positive charge will experience? What force does a unit positive charge will experience? Yes, it is electric field. This is basically the definition of electric field. If I ask you what is electric field here, if you say E vector, then in the next question, if I ask you what does a unit positive charge will experience, what force does the unit positive charge will experience in this region, your answer would be electric field only. This is the definition of electric field. It is the force exerted on unit positive charge. So please answer. The charge present in this pendulum is q. The charge present in this pendulum is q. So what does a unit positive charge will experience? Your answer will be, sorry, electric field. So if unit charge experiences E, if 1 coulomb experiences E, then Q will experience Q times E. Q will experience Q times E. Obviously, it is a positive charge. Because it is a positive charge, if this is the direction of electric field, that means positive charge will experience force along this direction. So, in this region, at every point, what force does the unit positive charge experience? According to definition, it is electric field. At every point here, 1 coulomb will experience electric field. So if 1 coulomb experiences electric field, then Q amount of charge will experience Q times electric field. Simple. So here Q is experiencing Q times electric field. And because it is positive charge, it will experience force along this direction only. Clear? Clear? Now, because this thread of the pendulum is stretched, there will be a force which is called tension. Obviously, you know about tension from your class 11. But in the question, it is said that the pendulum is at rest. The pendulum is at rest. It is in equilibrium. That means the resultant of these 3 forces must be 0. Now what we will do, we will break the component of this tension, or we will break this tension into its rectangular components. So if this angle is theta, then obviously this angle is also theta. And if this is tension T along this direction, then the rectangular component along this direction will be T cos theta. and along this direction the component will be t sin theta. So we have resolved, or you can say we have broken this tension into two vectors, one is t cos theta and another is t sin theta. Clear, students? And we know that this pendulum, this bob of the pendulum is at rest. That means it is in equilibrium, or you can say along horizontal direction t sin theta must be equals to QE, which is the force on the pendulum due to electric field. This force must balance this force, or you can say this force is cancelling this force. Clear? Now along vertical direction t cos theta is balancing mg, or you can say t cos theta is cancelling mg. Clear, students? So we got two equations. Now let this be equation number 1 and let this be equation number 2. So now we'll divide equation 1 by equation 2. If we divide equation 1 by equation 2, tension and tension will get cancelled out. Sin theta by cos theta, it would be tan theta. Clear, students? Which is equals to QE by mg. We know the value of g, it's 9.8. We know the mass of the pendulum, it is given 80 milligram, or you will write 80 multiplied by 10 to the power minus 3 gram. So you need to convert this into kilogram first. So 80 milligram is 80 multiplied by 10 to the power minus 3 gram. But we know that SI unit of mass is not gram, it's kg. So 1 kilogram is 1000 gram, right? So 1 kilogram is equals to 1000 gram. So gram got cancelled out. It's basically 80 multiplied by 10 to the power minus 6 kg. So this is the mass. So we know the mass, we know the acceleration due to gravity, which is 9.8. We know the value of charge, it is given, it's 2 multiplied by 10 to the power minus 8. We know the value of electric field, it is 2 multiplied by 10 to the power 4. So we know the value of mgQE. So obviously from this relation we can find the value of theta, which is the angle made by this pendulum with the vertical. Now after we find theta, we'll put the value of theta in any of these two equations and we will calculate tension. Clear, students? Students, let us solve one more question. So question is calculate the electric field strength with this electric field required to just support a water drop. That means the water drop will be hanging. It will be like hanging. It is supported. That means the net force on that water drop will be 0. The net force on that water drop will be 0. It will be like this only in the air. Clear? So to just support a water drop of mass 10 to the power minus 3 kg. So its mass is given. So let us consider that its mass is m. If its mass is m, then it's obvious that it will have weight mg in the downward direction. It will have mg weight towards downward direction. And having a charge of 1.6 multiplied by 10 to the power minus 9 coulomb. That means it has a charge of 1.6 multiplied by 10 to the power minus 9 coulomb. Minus 19 coulomb. So it is already experiencing a force which is weight towards downward direction. So to balance this weight, or to cancel this weight, to cancel this force, there must be an equal and opposite force towards upward direction, and that force will be an electrostatic force. Now let us assume that in upward direction the electric field is E. In this region. That means at every point unit charge will experience force E. Now if unit charge experiences force E, then Q charge present in this water drop will experience force Q times E. Clear, students? If 1 coulomb at every point here experience force E towards upward direction, then this water drop has got a charge value of Q, then it will experience Q times E. Clear? So now if this water drop is in equilibrium, that means this force will cancel this force, or this force, electrostatic force, will balance the weight. So we will write QE must be equals to mg. Clear, students? So in the question you can see that it is written that to just support a water drop, that means the water drop will be in equilibrium. The water drop would be at rest in the air. Clear, students? So from this relation we can write that E equals to mg by Q. So we know the value of m, that is mass of the water drop, it's 10 to the power minus 3 kg. We know the value of G, it's 9.8. We know the value of Q, that is charge present in the water drop, it's 1.6 multiplied by 10 to the power minus 19 coulomb. So from this relation we can easily find the strength of the electric field. Clear?